Okay, good morning everybody. So today, just in case you're stuck taking a retake, this is the film and you can watch it later. But today's pretty easy. We're going to graph square root graphs. So one of the things you can do, I suppose, you can always maybe try and put it on your phone for Desmos, but it's faster to do it by hand. I'll show you in a second why, okay? Desmos, let me show, okay, real quickly. Let's see what shows up. Okay, I got a Y equals, and then square root. There's my square root of x, okay? Looks like that. But it's easy for me to do this, okay? Watch how I do it. I'm going to go square root of 0 is 0. And I'm going to go all the way to 4. 1, 2, 3, 4. All the way to 4 because the square root of 4 is 2. Oh, that's right. 1. Square root of 1 is 1. Okay, and then, so 1, square root of 1. And I'm not going to do these numbers in between because they're ugly decimals. Square root of 2 is about a 1.4. Square root of 3 is about a 1.7. Anyway, you got the idea. Let's go 1, and let's go 4, and let's go all the way to 9. 4, 5, 6, 7, 8, 9. Because square root of 9 is 3. And of course, it keeps going and going and going. Now, what we do also know is you can't take the square root of negatives. So you can't do square root of negative 1. You can't do the square root of negative 4. That won't happen. So there are no negatives unless you do I. But we want real numbers. So this is my parent function. Okay, so now what's domain? Well, it starts here. Domain's my x values. Domain is the x values, but it doesn't have any x values in the negative. So the domain is simply x is greater than or equal to 0. No negatives in this graph. What's the range? Well, it starts at a height of 0 and goes up. There's no negatives, so it's just y. Y is the y values. Y is greater than or equal to 0. Okay? Easy, right? Okay, now, example 2, we've got y equals the square root of x minus 2. All I'm going to do is take this parent function and move it down 4. Move it down 4. So I'm going to take this parent function, move it down 4. So this function here, fold this so you can see it. All right, I'll show you here. Hold on just a second. Fold it. Come on, fold for me. There you go. Good enough. So I'm going to take this function, move it down 4. So I'm going to go down 1, 2, 3, 4. And I'm going to do the same thing. I'm going to do my 1. Square root of 1 is 1. I'm going to go my 4. Square root of 4 is 1, 2, 3, 4 is 2. I'm going to do my 9. I'm going to go square root of 9. 1, 2, 4, 5, 6, 7, 8, 9. Square root of 9 is 3, and so forth and so on. Okay, so here it is. We just moved my parent function down. For domain, same thing. It doesn't have any negative values. It starts at 0 and goes over. So x is greater than or equal to 0 is the domain. Now, but the range starts at a height. Oh, move it up so you can see it. The range starts at a height of negative 4 and goes up. So the range is y is greater than or equal to negative 4, right? Start at negative 4, height of negative 4, and goes up. That's my range, okay? Example 3. So remember, if it's on the inside, it's the opposite. So we're going to move it to the left. 3, and then down 2. All right, so I'm going to go 3, 2, and I'm still going to do my same graph. I'm going to go over 1 because the square root of 1 is 1. I'm going to go over 4. 1, 2, 3, 4. Square root of 4 is 2. I'm going to go 1, 2, 3, 4. 5, 6, 7, 8, 9. Square root of 9 is 3. And I put it in there. And again, you can put this on Desmos, but for me, it's so much faster to do it this way. So, domain and range. Well, it starts, the x values start at negative 3, right? It goes from negative 3 forward. So the domain is x is greater than or equal to negative 3. And the range starts at a height of negative 2 and goes up. Y is, okay, there's my range. Domain and range, okay? Turn it over. Oh, cube roots. Well, let's check it out. If I put that on Desmos, let's see what that looks like. Can I even do a cube root? Well, I know one way I can do it. Can I do a cube root? I can probably do it as a 1/3 power, okay? I can probably do an x to the, back up, x to the 1 divided by 3. There it is. Now that's a weird looking graph. That's a cube root graph. But I'm going to do it this way, okay? These are the numbers I like. I like 1, 2, 3, 4, 5, 6, 7, 8. and I like -1, and I like 1, 2, 3, 4, 5, 6, 7, 8. You see, there is a cube root of 0. There is a cube root of 1. There is a cube root of 8. 2 times 2 times 2. And all the rest are decimals, ugly decimals. I mean, for instance, and the rest I don't really want because they're just decimals, like the cube root of 6, right? But 1.8. Nah, let's just use our nice numbers. And there is also a cube root of -1, which is -1, because -1 times -1 times -1 is -1. And there's also a cube root of -8, which is -2, because -2 times -2 times -2. So if I were to graph these, cube root of 0 is 0. Go over 1. Go over 1. What's the cube root of 1? 1. Now I'm going to go all the way to 8, because the cube root of 8 is 2. Now I can go further, but, I'm going to run off my graph. Cube root of -1 is -1, because -1 times -1 times -1. And the cube root of -8 is -2, because -2 times -2 times -2. So the graph looks something like this. It has this little bend right here, this little inflection point here. Looks like that. Okay, now, domain and range. Well, it's forever wide. All x values can be included. All x values. So my domain is x equals all real numbers. That's a symbol for all real numbers. Cursive R. And the range, well, it is going up. And it goes up forever. It always is going up. And it is going down. It's always going down forever. So the range is also all real numbers. Okay? Now, if I want to translate this graph, anything on the inside, so I'm going to go left 3 and down 5. So I'm going to take my parent function. I'm going to move the inflection point. That's the easiest thing to do, is move the inflection point. So I'm going to move this left 3 and down 5. 1, 2, 3, 4, 5. Okay, so I'm taking this graph now and just put it here. So I'm going to go over 1. The cube root of 1 is 1. I'm going to go over 8. Remember, 8, because the cube root of 8. 1, 2, 3, 4, 5, 6, 7, 8. Cube root of 8 is 2. Now there's a bunch of numbers in between. You can also put this in decimals, okay? From the inflection point, I go back 1. The cube root of 1 is 1. Go back 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And I go 2. And here it is. And again, domain and range, that's easy. There's my graph. Domain and range. Domain is x equals all real numbers, and the range is y equals all real numbers. Now, homework is not that hard, and you can use decimals, it's fine, but I'd rather have you at least, I do it by hand. It's much faster to do it by hand, okay? So if I go to section 4.4, nope, section 4.3, my bad. Section 4.3, and it even shows the parent functions here and here. But the homework we're going to do is page 121. We're going to go 1 through 4 all, and we'll let our extra be number 5. That's all you got to do, okay? All right, that's all I have.